I will talk about is what I say is digital twins to digital societies, and tell you about some of the work that's going on in the Netherlands that I'm involved with, a little bit about Destination Earth, and some horror stories I think Dirk will recognize, and maybe Peter will recognize, and then some example of a project that I'm doing with the city in Amsterdam on school segregation, where we're doing kind of modeling digital twins, but with their involvement. And maybe a question, some kind of food for thought about how we might go to citizen science with these digital twins, and if there's any dangers involved with that. So when I saw the title, the Mechathon and Digital Twins, it made me think of things like this. And I think Johannes gave some good examples of the way digital twins have been applied in the last few decades. You have these factories which have digital replicas. There may be online simulations that are running continually. When there's a backlog, they start to adapt, and it's all kind of self-contained and clean and nice. And as long as your sensors are not too bad, then you have a good idea. Now, it seemed like about 5 to 10 years ago that this digital twin terminology started to take off. And then it became a bit more about, let's say, humans and humanity. So Peter mentioned the virtual physiological human. There are now these two things, Destination Earth, which will be a new, or is now a European initiative. It's a big amount of money, about €250 million, that will be put towards this full-scale replica of the Earth. And that involves, well, climate modelers, people who want to get their models higher resolution. So instead of doing 1 kilometer voxels, they're going down to 100-meter voxels, and they want more data, faster, bigger databases, everything else. So in February of this year, quite a few of the people from these modeling communities, people who are advising the IPCC, they got together with a few sociologists and philosophers to talk about the implications of these kind of digital twins. And the nice thing for Dirk to know is in the current version of the Destination Earth, which is, keep in mind, supposed to solve climate change, there is no concept of the human. So if you take the human out of the climate system, presumably the problem goes away. So that's good news, right? The other interesting thing to know is they're kind of worried because as they've gone to higher and higher resolution and more data, these classic error propagations that they make, they get worse. So the story at the moment is as we spend $250 million, we make our models higher resolution, but our errors get worse. It's not a nice story. So we spent about a week, sat down in a room together, thinking along with the sociologists, people like myself who are doing, let's say, computational models of humans, about how that might be incorporated in some way. And one of the things that we talked about is the question of, okay, if a digital twin is the kind of thing that Peter described, which mostly it is, it's this collection or this zoo of models, who has the right to contribute a model? And who verifies that that model is correct? At the moment, the way the climate modelers are doing it is they send an email because they have a friend. They'll send an email with a data format and say, this is what my model outputs. Does that work with yours? Well, maybe not. We'll change it a little bit. So it's kind of this reputation that they built in historically to get things to work. If it's going to become large scale, that's not going to fly. This is going to be a repository. There is going to be, at least for the scientists, the idea that you can contribute towards it. But what if down this chain that Peter explained, there's one of these models that's quite fundamental in the whole process is completely wrong? And how do we check that? So this idea of auditability, transparency is important. And then we also talked about the question of who will have access to it. So is this going to be a public good where everyone can use this digital twin to check whether they should buy a house in the Netherlands and whether it's going to get flooded in the next 30 years, and whether companies like Shell can use this digital twin to actually prove that their drilling is safe. It's actually good for the environment rather than bad for the environment. So these things are not trivial, far from trivial. And this is not talking about the computational challenges that come with this. So when you're going to run these models at large scale, you're going to do things like uncertainty quantification, sensitivity analysis. You need these massive computers to do it. The good news is, maybe some of you are aware, that LUMI is one of the largest European supercomputers now available. I think it's number 3 in the world. Very energy efficient. It's in Finland, so they use the heat from the computer to heat the building. So all well and good. They have allocated some of their supercompute to these digital twins. We had a conversation with the director there, and one of the things is, if you're going to put human data in there, if you're going to try and understand how climate might impact different communities, where people who are already deprived are differentially kind of affected by some policy, you need this data. They have no idea about how to share this data at the moment. So it's a European-wide thing. The GDPR does not allow this data to be transferred. So the answer was, well, it's left to the project. So it's not all, I think, bad news. Within the Netherlands and within EOS, we have a small initiative, which we call Digital Netherlands. Little bits and pieces are going on with that. And there's an organization across the Netherlands called Odyssey. Some of you may be aware of it, where it's brought together sociologists, economists, mainly from the non-hard sciences. They provide computing services to do large-scale sociology, basically, data-driven sociology. Most of the people who are using this are people who are doing network analysis, static analysis. We are one of the few at the moment using things like agent-based models to actually run these things on the computer. What they've done, and I think we heard from Evangelos yesterday, the story of CBS. So CBS, the Central Bureau for Statistics in the Netherlands, they have this microdata. It's the largest database of its kind in the world. No other country collects all its personal information in one location. Think about that what you will. It's also part of the reason why the Razzia, the 75% of Jewish people were found in the Netherlands, because they've had a very, very long history of accurate data about their citizens. What the CBS have done now with Odyssey is they provide a way for you to log in through their secure server. This is all done through biometrics. Your internet is shut down on your machine, but now you can actually tunnel through to the National Supercomputing Center to run kind of large-scale analysis, really large-scale analysis. So we are one of the first kind of prototypes of that, with the idea to also use synthetic data in secure ways. And we're doing that with this project that I mentioned, which we call the Compass Project. It's about primary school segregation in the Netherlands. And this is together, a bit like in the format that Peter described, together with the inspectorate, together with the city. At the moment, we've not involved the citizens, but that would be something that we would aim to do. And the idea is not to make predictions, is not to tell the inspectorate, do this to this school. It's really to help them understand the processes. Because when you talk about complexity, and you talk about kind of knock-on effects that can happen, where maybe closing the most segregated school in a neighborhood could actually lead to more segregation. These are things that once you've seen the model run through once, you actually understand. But before you've seen it, it seems counterintuitive. So we kind of have some success stories. I will go to them next week, where we're using kind of theoretical models to explain phenomena that you see and give the inspector the assurance that actually what you're observing is not unusual. It's what you might expect. All the way to doing kind of parameter estimation with kind of advanced AI techniques to see if we can take this microdata at scale of the city and estimate parameters for every individual in the city. And then one of the questions that we're interested in is about this oversupply of primary schools in Amsterdam. Because the Dutch travel everywhere on bikes, this makes segregation an easy phenomenon to happen, because everybody has around 9 schools within a kilometer to send their kids to. So if you have that choice and there is a preference, it easily segregates. But now the kids, so less and less kids in Amsterdam, so they have to close the schools, and they want to know how to do that. Rather than just closing it randomly, can they do this in some guided way? So I think the message is, I agree, this is very dangerous. I don't think the people who are applying these digital twins at the moment really know how to do it. Also, the access to these things, I think, is a big question. And the proper way to kind of bring in the citizens, I think, to explain to them the processes that are happening and why the decisions are being made. I think there's a lot to be done there, and I think it's quite exciting. So with that, I will stop.